So we're talking about exponential functions. Yesterday, after our penny activity, and from what we learned on Friday, we talked about exponential functions and how their form is f of x equals a times b to the x. So every exponential function is going to have this form. So a, that always represents your initial value. So whatever the function is starting at, whatever the situation is starting at, that's going to be your a of your problem. B, that was your ratio. That was how much you were either increasing by or decreasing by. If you were doubling, tripling, or decreasing by percentage or increasing by percentage, that was always going to be the B. And then X was whatever your input is. If it's number of years, time, number of rounds, whatever that is, that was always your X. So we had two types of exponential functions that we talked about yesterday. We talked about exponential growth, where it was increasing, and exponential decay, where we were decreasing. And both of these show up in different situations. So for exponential growth, sometimes we ran into situations where you were increasing by a certain percentage. And whenever we were trying to find that B, we would always do 1 plus our percentage. So if you're increasing by 7% every time, you would do 1 plus 7%, or 1 plus 0.07. And that was your B you would use in your situation. Same thing with exponential decay, except the only thing is you're subtracting. So if you're decreasing by 7% every time, you would do 1 minus 0.07, which would be 0.93, and that would be your B. And so the biggest thing that I think I see students do when, or in the past at least, when I've seen them do exponential functions, is they want to take that percentage and they want to put it in as the B of their problem. So they see a situation, they see that percentage, and they want to place it in as their B. But we always have to remember, it's either 1 plus that percentage or 1 minus that percentage. The only time where you're actually going to use that number is if you see the word like doubling, tripling, or cutting in half, or cutting into thirds. Those are the only time where we're actually going to use those actual words. But if it's a percentage, we always have to do the 1 plus or the 1 minus. So that's just a mistake I typically see students do in the past. So hopefully that won't be an issue. Any questions before we dive into some situations? All right. So the fizz at the top of a glass of pop decreases its height by 4.3 or 43.5% every second. If an 18 millimeter tall, or the fizz is 18 millimeters tall, how tall it would be after 6 seconds. So with these, we just want to look at some situations, be able to determine how can I create that function, and then how can I then evaluate it. For evaluating, we're going to need to use those calculators because doing it on the phone is pretty hard because you have to like turn it sideways, you have to find that special button, and then you have to hit it, and you have to hit the other one. So I recommend just doing it on the phone, or doing it on the calculator. So I have those here for you if you would like to use them, in whatever format you would like. So those shouldn't be able to do all the same thing. It's just not expansive. Whoa. All right. Did everyone get a calculator? All right. Okay. Maybe. So once again, with our exponential functions, we're always using f of x equals a times b to the x. So our goal is just to figure out what is that a and what is that b, and then what are we going to input as our x in order to solve this. So thinking through, what does a always represent in our situations? What was that? So it will represent our y-intercept when we do graphing. But for right now, in these situations, it's always going to represent our initial value. It's always going to represent the starting amount. So thinking through this, with our fizz, our little glass of pop, what was its starting height, or what was its starting amount? 18 milliliters. So that's going to be our A. a in our function. So we know f of x is going to equal 18. And then we're going to need to figure out what that b is. So first thing to decide, are we increasing or are we decreasing with this? So the fizz at the top of the glass of pop decreases its height. So we know it's decreasing, so we know it's going to be an exponential decay. So whenever we're dealing with exponential decay, when we're trying to find out b, it's always 1 minus our percentage for decay. So what is our percentage in this problem? 43.5%. So we have to do 1 minus 43.5%. Now whenever we change from a percentage to a decimal, how do we change that? How do we actually make that?
Divide by 100.
You can either divide by 100, or you can move the decimal places 2 places to the left. The same, dividing by 100 is the exact same thing. And so we are doing 1 minus 0.435. So that's going to be our b once we figure out what that number is. So 1 minus 4 or 0.435. And we should get 0.565. So now that we know what our b is, we can plug that into our function. 0.565. If I can write correctly. And then raised to the power of x. So we have our function, we have our exponential function. That's one part of our situation that we wanted to find. Now the question was asking if the fizz is 18 milliliters tall, how tall it would be after 6 seconds? What was that? It's going to be gone? Well, it's definitely going to be smaller. So all we need to do is we need to plug 6 as our input into our function, because that's going to be seconds are passing by. And then we can determine what this is on our calculator. So for solving these on the calculator, you just want to type the whole thing in directly into your calculator. So we're going to type in 18 times 0.565, raise it to the power of 6, and hit enter. Don't worry about like breaking into pieces. Typing the whole thing in will reduce your possibilities of making an error. And so let's see what that number gives us. So you got 18 times 0.565 raised to the power of 6. What? So what did you find?
0.0975.
0.0. Did everyone get that?
No.
What did you get?
I got 5.85554893047.
Okay. So 0.585. Here, Dylan, show me what you. Okay. So we got 0.585 milliliters. When you do these, you're probably going to get a lot of decimal places. It's probably going to go on and on. If you look at that problem with like 5.85562, whatever, you really only have to go to 2 or 3 decimal places. I don't want you to have to copy down the whole problem. Just put down the first or second decimal places, go to the hundredth place, and that's fine. So 5.585 milliliters would be your answer. Now, do we have questions on how we were able to figure out what some of these certain values are, or where we got some of the numbers from on this problem? Okay. So a herd of gazelles at the Columbus Zoo has 14 members. If the population of the herd grows by 15% every year, how many gazelles will be in the herd after 7 years?
Does the Columbus Zoo have copyright? You might have just broken it. Trust yourself.
Okay.
So it's not a big thing.
Let's focus. So once again, we always want to make our function first. So we need to figure out what is that A and what is that B going to be for my situation. So A always represents our initial value. So what are we going to start with for A? 14, because our herd starts with 14 members. So we know we'll start with f of x equals 14. Now we need to figure out what that B is. So are we increasing or decreasing on this situation?
Increasing.
Increasing. Our population is growing. And so
They say 15.
exponential growth is 1 plus our percentage. So if we are 1 plus 15%.
16%.
We can do 1 plus, and then as Ashton said, we can either divide 15 by 100, or we can just move the decimal places 2 places over, and so we have 0.15. Which 1.15 will be our B for our situation. And then X will always be above our B. Now we have to figure out what is the input, what does the question actually ask? How many will there be after 7 years? So we know 7 will be our X in this situation. So 14 times 1.15 raised to 7. And then from here we have our full thing. We can input it in, and we can see what we end up with. So we can plug that into our calculators.
Jarvis, how to do the one thing where you insert the number?
You put the
If you hit second delete on your calculator, it will, that's your insert. Second delete. So you should
Actually,
All right, what did we find for our solution to this problem? Dylan?
I don't know how you get those.
The exponent. So there should be a okay.
Yeah, maybe he cut off the way.
So we got 37.24 gazelles, but is it possible to have 0.24 gazelles?
Definitely.
Yes, he definitely
No,
is.
like,
One just got
Yeah,
bald.
just flip.
No.
One just got
Oh,
bald.
I know what you need. You need.
So in a situation like this, because we're thinking about full animals, we need to round to the nearest whole number. So you can round that down to 37 gazelles is the closest whole number. And so that would be your solution. All right. So with these problems, the method is pretty straightforward. Determine whether you're increasing or decreasing. Figure out what the A is. Figure out what your B is. Figure out what your input is. Plug it into the calculator, and you're good. So if you can go through those steps, then most of these problems should be fairly simple, and it should be, once you get those steps down, it should be pretty easy, pretty repetitive. So take a moment, see if you can do this one on your own. See if you can figure out what is my A going to be in my function, what's my B going to be in my function, and then see if you can figure out what the answer is at the end.
Jarvis.
What did we find for A of our problem? 24. Now, how did we end up with the B for this problem? So, B is always either going to be 1 plus or 1 minus your percentage. Why are we doing 1 minus our percentage? Going down. We're decreasing, so we want to minus. So our percentage was 23%. But if we think about that as a decimal, that's going to be 0.23. You can either divide by 100, or you can move your decimal place 2 places to the left. Either way, you'll get 0.23. What did we get for our B then, for our problem?
0.77.
0.77. So once again, a lot of times we want to put 0.23 in for our solution, or in for our B. We always have to remember it's either that 1 minus or the 1 plus. I think that's the biggest mistake I see often. So we have 24 times 0.77. What is our exponent we're using? 6. It's happening after 6 bounces. So we plug that whole thing in the calculator, and what did we end up with?
5.
5 or 5.002. So it's 5 feet. Are we okay with this, or do we have questions on how we ended up with those numbers?
No.
Okay. It is 12.
What the flip? That's way too late for bedtime.
All right.
Is that so? Yeah.
So this question is a little bit different. 2 trucks are being sold at a dealership. One truck is worth $14,000, and the other truck is worth $10,500.
What are the prices on that?
As soon as a vehicle is bought and driven, it depreciates in value. So depreciate means is like it's worth something and it's worth less and less and less the more you use it. So as soon as you drive a truck, or as soon as you drive any vehicle, it starts depreciating in value. So if you buy a new car, as soon as you drive that thing off the lot, it's worth less than what you bought it for, which is kind of terrible, but that's how life works. So as soon as this vehicle is bought, it starts depreciating in value. So the first truck is depreciating at 7% every year. And the second truck depreciates at 2% every year. So we want to figure out which of these trucks will be worth more after 5 years. So we have 2 functions occurring in this situation. One for your first truck and one for the second truck. We want to see which one will have a higher value after these 5 years. So we're going to need to create 2 functions on this problem. Do you want to try to do them on your own, or do I do them together? What do you want? Together?
He's becoming a
How about let's do the first one together? We'll do one truck together, and I'll let you do the other truck alone.
Let's do this.
All right. So for our first function, we need to figure out what is our a going to be for this function. What is our starting value for this truck? 14,000. So we know our a is going to be 14,000. Then we need to determine what our b is. Boys, Dylan, let's go back to your seat. Ashton, let's focus and stop throwing on the board, please. We need to figure out what our b is going to be for this function. So remember, are we increasing or decreasing on this? Decreasing. We're depreciating a value, so we're getting less and less valuable as we continue driving this truck. How much are we depreciating by it? 7% or 0.07. So we know b is going to be 1 minus 0.07, which should give us 0.93 as your b for your problem. Now, how many years are we valuing this truck at? After 5 years, what is the worth? So that is our first function, 14,000 times 0.93 raised to the 5th. So see if you can do the same thing for the second truck. See if you can determine what is my initial value, what is my depreciating value, and then how many years, if I can get this to come back. What did we find for the value of the first truck? Using that first function, what did we find this next to be? 9491.1 something.
That looks like my answer. Yeah.
So $9,491 was the value of the truck after. Okay. So $9,491 was the value of the truck after 5 years. Now we have to think, what was our function for the other truck, our second truck? What did we find for that function? What did you get for your function that you put?
I put 10,500.
Okay. So 10,500 times 0.98. So if we're decreasing by 2%, 1, if we move that 2% into a decimal, it's 0.02. 1 minus 0.02 is 0.98. And then we raise that to the power of 5. And what do we find for that value of our second truck? Yeah, this is the second one. That.
No, the 949.
Oh, this was for our second one?
Yeah.
Okay. What did we find for the value of the first truck then?
It was 97.
Say that one more time with me.
9739.
9739.
I told her.
Point something. So which truck would you want to take then?
I want to take the one that's cheaper because that's less money I have to spend.
So there are that was obnoxious and not needed.
Loud and not you.
Alright. So the value of the first truck would be worth just a little bit more after 5 years. After 6 years, it's probably going to be worth a little bit less than the other truck because this one decreases at a less value. But after 5 years, it was still worth more. Are we feeling a little bit more comfortable with these exponents?
Yes.
Okay, good. So this is going to be one of the main things you're going to be quizzed on Friday. Just being able to, given a situation, can you create the function from that situation, and then can you solve for the value after so on? Do any of you guys have a savings account?
Yes. I know.
Yes.
So, savings accounts, the reason, let's listen up. The reason you want a savings account is because as you put money into it, the bank is using that money to give it as loans to other people. So, as you put money into a bank, they are then using that money for loans for other people. But the thing is, in order to allow them to do that, they are paying you to hold on to your money. So they pay you through what's called interest. So as you leave money into a bank account, you build interest on it. So they actually pay you to just let money sit in their bank account so they can use it for whatever needs and loans that they have. And so every couple years, or every year, or every month or so, depending on how often your interest builds, you get a certain percentage of how much money was in your initial bank account. So you might have 1% interest. So if you have $100 in your bank account, the bank clerk multiplies your value by 1%, and then they add that money into your bank account. So it's basically free money for just letting your money sit there.
But if it's 1% and they multiply it by 1%.
Well, if you have 1 cent and they multiply it, then you're not really going to gain that much. So typically your interest rate is going to be pretty small, but if you let your money sit there for a while, it can build for a while. But the thing is, that it depends on how often your money is compounded. So, how often your money builds interest. So if it builds interest once a year, it's compounding annually. While some interest might build interest every month. So every month, the bank looks at how much money you have in the bank and they'll put interest on it. Or every day, the bank will look at how much interest and they'll pay you interest for that.
Dang, I don't want that deal.
And so this is called a compounding interest or compounding percentage or compounding interest formula. So there's a formula on how to calculate how much money you'll have in the bank. There's a formula on how to calculate how much interest is in the bank after so many years. And this is based off of our formula that we've just talked about. So it uses a lot of different letters and a lot of different variables that represent things, but don't let the variables scare you. So A represents your balance at the very end. So however much money you have at the very end, that's like your amount. P is the principal. That's your initial amount of money that you put in the bank. So if I start out my savings account with $12,000, my principal was $12,000. So this is like your A from our original function. R is your annual interest rate. So if you have an interest rate of 3%, that's what R is going to be. N represents the number of times it compounds. So there's a couple different options. If it's compounding every year, you're only earning interest once a year. It's only going to happen once. If you're earning interest every month, it's happening 12 times a year. So N would be 12. If you're earning interest every day, it would be 365 times a day.
Okay.
365 times a year.
I want 300.
So N represents the number of times that happens in a year. And then T represents the number of years that happen, or the number of years that you leave this money in the bank. So I'm not going to have you memorize this formula. I'm not going to have you. It's just, this is an example of where these exponential functions are used in real life, and I just want you to be introduced to this. This is something we go over in senior math when they do stuff. So in order to actually use this formula, you might encounter something like this. So your parents place $2,000 in a compounding account that has an interest rate of 4.5% compounded monthly. We want to figure out if they put this money in right when you are born, how much will there be in 18 years when you graduate high school? Say it's for like your college savings or something. So the initial amount, that was your principal. That's going to be your P. That's going to go in your function. This annual interest, it always is 1 plus n or r divided by n. Why do you think it's 1 plus? Where do you think that 1 comes from? If we think about our original functions. So whenever we were doing our original functions, that b value was always 1 plus whatever your percentage was, or 1 minus your percentage. Now, if we're increasing, the bank is paying you more money, it's increasing its value, it's going to be 1 plus. So that's where that 1 plus in this formula comes from. R represents your percentage, so that's a percentage of 0.045. And then the reason they divide by n is because they don't want to give you the full interest rate every month or every day. And so that's why the n is in there. But that's still different from our normal formula. So we divide by 12 because it's compounding monthly. And then you raise it to the power of 12 times the number of years, which is 18. So this looks a little bit different. It's a little bit more complicated than our initial functions that we're used to, but it's built off of that function. It uses the same formula. It uses the same ideas. It's just a little bit different. But this is what your bank does whenever you put money in the bank and they actually pay you for it. And so you could actually input this whole thing into the calculator. And that's how much money you would have after 18 years with this formula. So you can just type in the whole thing, 2,000 times parentheses 1 plus 0.045 divided by 12, close your parentheses, raise it to the power of 12 times 18, and your whole answer is $4,489. So by just leaving this money untouched for 18 years, you earned an extra $2,489 for free, which is pretty nice, and that's why it's important to have a savings account. That's why you should get a savings account early. Talk to your parents about it. Put some money in.
I'll put $5 in
The bank is our-
I do not work for a bank.
Hey, Jarvis,